Thank you for your interest in packet design. In this video, we will look at how a network operator can use Packet Design's Route Explorer to analyze the impact of an OSPF event on the network and find the root cause of the issue. When it comes to routing issues, many last only for a few minutes and then disappear by the time the problem is reported. So when you want to go back in time and analyze what happened or the impact on the network, there's no data to go back to because the path has converged and everything is back to normal. This also causes many trouble tickets to be closed without a resolution in many service provider networks. In this use case, let's assume we are the network administrator managing an OSPF network. It begins when we receive alerts for a neighbor change in the OSPF backbone area. We can check the events that occurred in the past from the historical events report accessible from the reports tab and selecting events from the dropdown. The events show that the ORD121 router has triggered a drop neighbor event with ORD122, which is connected through this interface. The list also shows us another event 20 minutes later where the ORD122 router has been added as a neighbor by the ORD121. Now, to analyze how these events affected the routing performance, we go to the map view and analyze the path originating from ORD121 to a destination in the network. Here we select the source and destination of the path and then drill down into it. Here the solid line represents the forward path and the dotted lines represents the reverse path. You can watch another video on our website, Troubleshooting Network Issues with Packet Design Explorer Suite, for a demo on how to quickly search for a path. After the path has been selected, we can drill in and get to the MiniMap View, which shows the specific path we are analyzing with the participating devices. Once in the minimap, we select the time range to analyze and the granularity of the playback and hit the play button. From the playback, we can see that the link between ORD121 and 122 goes down and the traffic taking a different path. We can then pause the playback to analyze the performance of the path. The metrics of the path show that while the link utilization is less than the baseline, one of the devices along the path is showing a high number of errors. The latency report also shows that the new links have much higher latency, which means that the new path is less than the optimal path for directing traffic. To further analyze what possibly caused the issues, we can drill into the specific link that had issue and analyze the performance of the link and the devices associated with it. Here we can see the performance of the path and the performance of the devices and links associated with the path. Drilling down into the ORD122 router shows that while the device availability is at 100% and the utilization is less than baseline, the CPU utilization is much higher than the baseline value of 28%. Back from the minimap view, we can see that the ORD122 router had a number of errors generated on the link that connects to 121, which might have caused the drop neighbor. With this actionable information, we can log in into the device and check what errors were triggered on the router and if they caused a drop neighbor event to occur. As you can see, with the Explorer Suite, you can quickly get to the root cause of routing issues and close tickets with a definitive resolution. Thank you for watching and do check out the other videos and resources on our website to learn more about Packet Design's Explorer Suite.